Now that you know what prime and composite numbers are, we can find something called a prime factorization for a number, for a composite number. When a composite number is expressed as the product of prime factors, it's called the prime factorization. One way to find a prime factorization of a number is to use a factor tree. So basically what we're going to try to do is try to pull out all the factors, all the numbers we would multiply together to get a composite number that would give us all prime factors. Now, take a look at these steps here, and you can write these definitions down. You want to pause the video, and then I'm going to show you an example. So step 1, write the number you're factoring. Step 2, choose any pair of whole number factors of a number. In other words, try to find two numbers that equal that when you multiply them. They picked 4 times 5. They could have picked 10 times 2. You don't want to pick 1. You don't want to do 1 times 20 because you can't factor 1. You can't make 1, you can't branch out 1. I'll show you what I mean later. And then if the number is prime, you would stop, no more branches. But if the number is not prime, you continue to branch it until you have all prime factors. So 4 is the product of 2 times 2. Now since 2 is prime, and this 2 is prime, and 5 is prime, we have the prime factorization. You continue to branch out like a little tree until you have all prime numbers. If we multiply 2 times 2, that's 4. 4 times 5 is 20. So 2 times 2 times 5 is the prime factorization of the number 20. If I want to write that using exponents, I could keep it like that, 2 times 2 times 5. That is the prime factorization for the number 20. I could also, though, write it using exponents. Since there are 2 2's, I would write 2 to the power of 2 times 5. And that is my prime factorization for the number 20. These are all the prime numbers I would multiply together to get 20. And you'll always get the same answer no matter what you start with. Okay, I want you to make sure you copy down this example if you haven't written anything yet. I'm going to show you how to find the prime factorization for 90. I'm going to start with 2 little branches, and I'm going to think of any 2 numbers I can that when I multiply together, I get 90. So 2 easy factors of 90 are 10 and 9. 10 times 9 is 90. Now I'm going to stop and check to see if either one of those are prime. 10 is not prime, so I can continue branching it. If you can think of 2 numbers that equal that, then continue branching. 2 times 5 is 10. And then again, I'm going to ask myself, is 2 prime? And that answer is yes. So I'm finished with this branch, and I can circle it. Is 5 prime? And that answer is yes again. I can't branch 5 out anymore, so I circle it. Going back up to the 9 here, that is not prime, because 3 times 3 is 9. And 3 is prime, and 3 is prime again there. So I now have the prime factorization for 90. I can start this however I want. I could have done this a different way. Let's say I started with 45 times 2. 45 times 2 is 90, isn't it? I can start with any factors I want and continue branching, and I will get the same result. Take a look. I can't branch 2 anymore, that's prime. But I can branch 45, that's composite. So 9 times 5 is 45. 5 is prime, so I'm finished with that. But 9 is not, so I continue branching. 3 times 3 is 9, and now I've finally got some prime factors on these branches. So now I have an answer of 3 times 3 times 5 times 2. 3 times 3 times 5 times 2 is the prime factorization for 90. And look, that's exactly what I got over here. A different order, but the same result. 2 times 5 times 3 times 3. These are the exact same results. No matter what numbers you start with, you're going to get the same result when finding prime factorization for a number. How would you write that using exponents? You want to try? Pause the video if you want to try. Here's how I would write that using exponents. It doesn't matter what order I put my factors. There's only 1 2. There's only 1 5. but there are two 3's. So I'm going to put 3 to the power of 2 using an exponent. Okay, I'd like you to try finding prime factorization of 24. I would like you to pause the video and try to find the prime factorization of 24 on your own. All right, let's go over your answer. 24 can be branched many ways. Okay, I could use 12 times 2. I could use 3 times 8. I could use 6 times 4. No matter what you started with, you should have the same final result as me. I'm going to start with 6 times 4. Okay, keep branching. 3 times 2 is 6. 2 times 2 is 4. Add my times there. Now I have all prime numbers. And my final result is 3 times 2 times 2 times 2. Or I can write that using exponents since I have multiple factors. That would be 3 times 2, and since there are 3 2's, I would write 2 to the power of 3. Did you get this? Your factor tree might look a little different depending on what you started with, but you should have ended with this, and you could have it in any order. You could have 2 times 2 times 2 times 3, or any order. You could have 2 times 2 times 3 times 2. Any order of those factors is the right answer. So that's how you find prime factorization. Okay, something a little bit different. We have monomials. You also have to be able to factor a monomial. A monomial is a number, a variable, or a product of numbers and variables. 80x, 8x, these are all examples of monomials. X plus 5, x squared minus y squared, these are not monomials. Monomials are only numbers and letters, variables, that are multiplied together. Adding and subtracting of those parts are not monomials. You can factor these as well. It's pretty easy. Take a look at this example. 11r to the 4th power times s. If I want to factor a monomial, I follow the following steps. First thing I do is make a factor tree for the number. All right, that's going to be easy because 11 is prime. 11 is a prime number. There are no factors for 11 other than 1 and 11. So I leave that 11 times, and then I'm simply going to factor out these letters. There are 4 r's, so I'm going to write r times r times r times r. That's simple. And there's 1s times s. This is what we call prime factorization of a monomial. Simply writing out all the letters. That's it. Take a look at this one. Make sure you're writing these examples down. Negative 28, a squared b to the 3rd power. First, I'm going to make a factor tree for 28. So I can use 4 times 7, and then 2 times 2 times 7. There's my prime factorization. So I'm going to write that 2 times 2 times 7. Factor out my letters. A times A, there's 2 A's. 3 B's, so 1, 2, 3. There's one more little thing tricky about this. The last tricky thing is this right here. Because there is a negative, I have to factor out a negative 1. So in the very beginning, I'm going to put a negative 1. Because there's a negative, it's like I would have to multiply all of this by negative 1 to make the whole monomial a negative. All right, make sure you write that down. You can rewind the video and watch that again. And we will practice factoring monomials tomorrow in class. Make sure you bring all your notes, and I will see you then.